Hello, my name is John Deck. I'm going to tell you about the Biocode Field Information Management System, or FIMS, and this is a tool for field biologists and researchers to collect data in the field and publish it online. The FIMS system manages data in the field that pertains to collecting events, preparing specimens, and undergoing tissue subsampling. System requirements are for offline data entry. Data needs to be entered in the field where there's not an internet connection. And it has to be robust in terms of it can't fail while someone's in the field. It needs to be rock solid. It needs to provide for data validation, and it needs to provide global unique identifiers at the source of collection and retain and archive all versions of data sets. The FIMS workflow begins with a project configuration file, which you see in the upper left-hand corner in the gray box. This configuration file is set up once by a project administrator or a developer. Once it's set up, the users can then use the system. All of the user functions are highlighted by the blue boxes. It begins with a spreadsheet template, which is generated from the website. And once the user generates a spreadsheet template, they can enter data onto the spreadsheet. Then they can proceed to data validation and then uploading their data. Once the data is uploaded, you'll see the box in the lower right-hand corner, which is gray. There can be an online query from LIMS systems, or query from any other downstream service. Generating templates is done using the Spreadsheet Template Generator. This is available under the Tools menu, and when you generate a spreadsheet template, you choose your project that you are a part of, and you'll see that it'll open up a list of options on the left side of the screen here, where you could check or uncheck different boxes that correspond to different columns that you want to have in your particular spreadsheet. The list of columns under what you see here, the default group, are the entire list of columns available for the entire project. Particular users may not want to collect every single column. There are certain columns which are mandatory for the project, and these columns here you'll see are checked and they are disabled and grayed out here, so you can't uncheck them. Other boxes are checked by default, but you can uncheck them, and then there's other boxes which are optional, which are unchecked by default, and the user can go in and check those. If you click on the little DEF hyperlink next to, say, material sample ID, you will see, and any of the other column names, you will see a definition, and you will also see any particular validation rules which are enforced for this column. Once you are done selecting all of the columns you want, you can click on the button that says Export Excel, and that will export to an Excel spreadsheet. Here we see an example of a spreadsheet that was generated using the template generator, and there's several tabs on the spreadsheet that are downloaded. There's an instructions tab, there's a samples tab, a data fields tab, and a lists tab. The data that you want to enter from the field is entered in the samples tab, and you'll see that there's 3 columns here that are shown in red. Those ones are mandatory; they have to be filled out. All of the other columns in black are optional, and you'll see that in the example here in phylum, there's a lookup list. So if you click on these cells, you'll see a pop-up list of the available phyla for this particular project, which are tied to the lists tab. So it's important to note that all the data, this is just a typical spreadsheet. You just fill in data here, and you can save it, you can do what you want with it. You don't have to be online to fill it out. It can be done easily in the field. Now we get to the data validation step, and this is where all the fun happens. You choose your file using the FIMS spreadsheet choose file link. Navigate to the file that you just filled out, your spreadsheet file. It should automatically pick your project for you. If you want to upload your data, click the upload box, It will then ask you for a dataset code. You can fill in the appropriate dataset code that you want to identify this particular spreadsheet with. And then when you click submit, it'll go through the validation process. And in this case, it returns with one warning and an error as well. And the warning says that there are required columns that have not been found. And the error says that the material sample ID column is defined as unique, but some values are used more than once. So the data here needs to be fixed before we can proceed. Once the errors have been fixed on the spreadsheet, save the spreadsheet, go back to data validation, repeat this step, and you'll see that now we don't have any errors, but now we have just the warnings, and we can choose to continue if you want, and press the continue button. After you press submit on the previous slide, you'll see that the rest of the output just shows that your data has been successfully uploaded to the online system. The data format that we have on the back end is a flexible format enabling many different projects to be stored in the same system, all of which have different schemas and different requirements for their data. So the triple store format is a very flexible format which is dependent upon the XML configuration file which was defined in the first step. In this example, it shows that there's GUIDs being assigned, there's references to global standards for naming items, and there are property values associated with each of these triples as well. Finally, once the data is loaded, each project has a set of data sets which have been loaded. And in this example, there's just, you can see that the project is Indo-Pacific database, and there's two spreadsheet data sets loaded. One is called Demo, and another one called Demo L1. These are just demonstration data sets which I've loaded for the purposes of this demonstration. But you can choose one or more data sets for every project, and you can add filters into the query, and you can visualize your results using a table output, using Excel. If you choose Excel, it will download an Excel spreadsheet with your outputs, or KML, which will output the data to Google Earth or Google Maps as well. And these are all built on REST services, so the LIMS plugins and connectors to other systems are easily built using connectors, so people can connect to particular data sets, particular projects, particular versions of data sets as well. Thank you very much for your time, and if you have any questions, you can contact me. My email address is listed on the last slide here, as well as a couple of websites that you can go to. One is the Google Code repository that provides information on how to set up project files and how to get started in developing the system, or if you just want to dive right in and you're a user and the project's already been set up for you, you can go to the bicycle.org/Biocode FIMS site.